Guys, just wait for 2 minutes. Let the other participants join. Good evening, everyone. A warm and pleasant welcome to all the participants joining us for today's webinar, Explore VLSI Industry Insights, ASIC Flow and Career Roadmap, organized by IEEE Sir CRRC OU Student Branch, Department of Electronics and Communication Engineering, Sir CRD College of Engineering. At the outset, I would like to extend my respectful greetings to the for today's host of the session, Mr. Indra Reddy sir. And I would like to extend my respectful greetings to our IEEE Student Branch Counselor, Sir R. Satish sir. Your continuous guidance and support have always been a great motivation for the student community, sir. We would be honored if you could spare a few moments to share your valuable words with us.
Hi everyone.
Thank you.
Good
Shall I
evening.
speak?
Yes, Satish.
Yes, sir. Today's resource person, Mr. Indra Reddy, VLSI Design Verification Engineer in Semi Technologies Managing Director, and our respected head of the department, Dr. PHS Tejamurthy Garu, all my colleagues and IEEE Student Branch Chair and other body members, and my dear student friends. A very warm welcome to today's webinar on VLSI technologies. At the outset, I would like to thank Mr. Indra Reddy for accepting our invitation, and we are honored to have you, sir, as the resource person for this session. Sir, on behalf of my side, a small request for you that I request to guide our students in exploring career opportunities in VLSA domain, such as emerging trends and the future scope of VLSI and various career roles like design, verification, and testing, and what industry is expecting from our students. If you could explore these areas so that it will be very much beneficial to our students. And once again, I thank you very much, Indra Reddy sir, for accepting our invitation. Thank you very much.
Thank you very much, sir, for your encouraging words. Coming to today's webinar, Explore VLSI aims to provide students with practical insights into the VLSI and semiconductor industry. The session focuses on an overview of the ASIC design and verification flow, current industry trends in VLSI and career opportunities, and the skills required to build a successful career in the VLSI domain. The webinar is open to all students who aspire to enter the semiconductor industry. Now, it's my privilege to introduce our esteemed resource person for today. We're delighted to welcome Mr. Indra Reddy sir, VLSI Design Verification Engineer at Insemi Technologies, Managing Director of Silicon Verify, and external mentor at GUVI and other academic and industry institutions. Sir has vast industry experience and has guided us many students towards successful careers in VLSI. We are truly grateful to him for joining us today and sharing his expertise. Without further delay, I request Mr. Indra Reddy sir to take over the session and enlighten us with his valuable insights. Over to you, sir.
Thank you, Priya. Okay, let's start the session. So, before starting the session, let me introduce the person. Okay, I'm Indra Reddy. Okay, design verification engineer in Semi Technologies. Okay, and as well as MD of Silicon Verify. So, let's talk about the VLSI. VLSI is very fast growing domain currently. Okay, comparing to other domains like software and embedded or PCB designing, either core side or IT side. Okay, but VLSI has a lot of growth. Recently, our governments and even private companies also, they are investing a lot of money. Okay, a lot of money to create chips. Okay, every day we are using a lot of mobiles, laptop, and even cars also. Cars also automated and lift, washing machine, everything. In all the things, there is a chip. But who created the chip? VLSI engineers. Okay, so VLSI is very important. Even in future also, it will be very important. Okay, but problem in VLSI is particularly for students after fourth year, I mean, after graduation or post graduation, they want to be come into VLSI field. But what about the market? Okay, there are some conditions in the market and requirements of the markets are very important. So being in the fourth year or third year, if you know the those conditions, then it will be helpful. So that's the main motive of the session today. Okay, let's start the session. Hopefully, okay. Let me know if there is an issue in screen sharing. Okay, and okay, let's start it. So the main goals, like today's agenda is what exactly VLSI and the growth of the VLSI and comparison with other domains. Okay. And the main hero of the session is ASIC flow. Okay. Most of the people know ASIC on, but internally they don't know. Even working professionals, mostly like 70 to 80% of the working professional doesn't know about ASIC flow in detail. Okay. Each step does a lot of things, but 70 to 80 people, 80% doesn't know anything about that. Okay. Before entering into VLSI, we should know about ASIC design flow. It's very mandatory actually. So we will talk about that and companies. There are different types of companies like small to large. It's called as service based and product based. Okay. I will explain about those companies also and reality for the students, how to get into the VLSI and how to get a job. Okay. How to get a successful career. I will guide and training institutes, career path, everything. I will guide you. Okay. So what exactly the VLSI? So if someone knows about VLSI, please share your words. Okay. Let's make it like a conversational based session. Okay. If someone knows about VLSI, please tell. Okay, you can turn on the mics and you can speak. No issues.
Designing chip with more number of transistors like lakhs of transistors we use to design a chip, sir.
Yeah, right. Exactly. According to the textbook definition, you told correct. But the main thing is, let me make simple. In simple words, it's just a transistors, billions of transistors in one single chip. Okay, one single chip, it has a lot of transistors, just billions of transistors today. Okay, so the process of placing those transistors on the particular chip is called VLSI, very large scale integration. Okay, just look at this, very large. Before this, there are small scale or medium scale like that. Even in future also, there is a ULSI, like ultra very something ultra large scale integration. It's a future. Okay. But VLSI is the main thing because in VLSI and very large scale only, we got a better growth. Like today, lot of processors uses 3 nanometer technology. Okay. Even companies are trying to create 2 nanometer technology also. Yes. For example, Qualcomm, Snapdragon 8 Elite and Gen 5, these processors are very latest. Okay. They are based on the 3 nanometer. What is this 3 nanometer? It's gate width. In transistor, the width of the gate, okay, it's very important. If that width is too small, okay, we can place more transistors on the one single chip. Okay. Uh, Maybe you will get one question. Why too many transistors in one chip? Okay. For example, using with a lot of transistors, we can do more things better. Okay. For example, the mobile earlier mobiles which has 1 GB or 2 GB RAM. Okay, and today we have a lot of differences compared to previously. Okay, this all development because of this improvement of the transistors. Okay, even there are a lot of technologies in the transistors. Basically now FinFET is the main technology we are using, but in the future with the FinFET there are a lot of technologies will come like chiplets. chiplets and MDM, like multiple modules in one single chip. Okay, future will be very good. Like a lot of technologies and our technology will improve. Okay, so what exactly VLSI is? Just simply placing lot of transistors on single wafer or single chip, and we can use it like whatever we want. Like we can program it. Okay, we can program that transistors. Okay, for example, let's think about one lift. Okay, in lift we will use a small chip. Like we will tell, okay, which floor we need to go, or two or four. Then it will take to that floor. Okay, we will give some commands and it will accept and it will do the work. Okay, so inside transistors are the main heroes. They will do the work. Okay, total work. Okay, every day we will see a lot of applications. Main thing is smartphones. Okay, everyone will use smartphone. Okay, everyone has one processor inside. It's called SoC, system on chip. Okay, SoC, system on chip. Smartphones it's very important in smartphone. And the laptops, digital cameras, and the cars like Tesla and all automatic cars based on the VLSI only. And healthcare devices, a lot of healthcare devices like pacemaker. Okay, those depends on VLSI only. Next, wireless communication, and most of the communications related like a 5G. Okay, these 4G, 5G, 6G, these modems need VLSI chips and the data processing. We know there are a lot of data centers like in Hyderabad or Bangalore or Vizag. Okay, these all centers based on the VLSI only. Like a RAM, memory, everything will create based on that small tiny transistors. Okay, and these are the applications. We will see these applications in daily life. Okay, okay. Let's come to the comparison. In the fourth year or third year, most of the people, students are fourth year, I guess, and they will have one doubt like which domain needs to be which domain is good in future. Okay, most of the people will take software IT. Okay, this is actually this is personal interest, but according it's kind of guidance. Okay, software or IT is very fast. Okay, compared to a daily technologies will change. For example, if we take full stack development, okay, there are a lot of frameworks, languages we need to learn. Every day a new thing will come. Okay, we need to be updated. And the main problem, competition. Too much competition and less jobs. Like for example, CSE people will join triple EC, mechanic, and everyone will join into that computers only, end of the day. Okay. So because of these high competition, most of the people are not getting the jobs, especially in 2025 and 2026. And with the recession, a lot of things happen. Okay. Getting a job is highly, it's very hard actually. Next, AI or data science. This is good actually, but the problem is no openings, no, not much openings, very less, very few. And moreover, they need experienced only. Okay, not the fresher ones. I know a lot of people, they did training on AI and data science. Okay, the problem is after completion of the training, they are getting one kind of problem. Like they don't have any experience, right? They will be freshers, but company needs 2+, 3+. Okay, so that's a problem. And embedded systems. This is part of core. VLSI and then embedded systems are like brothers, kind of. But embedded systems, like it doesn't have that much growth like VLSI. Okay, embedded systems practically it's a low, like a limited scale. We can't scale too much. Okay, if we scale too much, then we will get big devices, not small ones. But VLSI is different. Okay, I'm not demotivating other people which seek software. Okay, I'm just telling why VLSI is better compared to other domains. Okay, and specialization. Here, specialization is the main word. Like in VLSI, like we will learn something and we will do work on that. Okay, we will get that specialization and long-term demand. Okay, the meaning of this long-term demand is simple, like future growth. We need growth, right, for both people and technology. Like in the future, this VLSI will have too much growth. Like for example, today we are using some good processors. Okay, previously. Let's talk about the past and present. Then we will know about the future. Okay. Previously, in the textbooks, like in our textbooks or either JNTK or affiliated or any textbook, they will tell about 8085 processor or 8086 microprocessor or 8051 controller. Those are very basic. Yes, we should learn about that. But those textbooks are very old. Okay. They should include latest processor details also, at least basics, but they didn't. So the problem is student learned only basics, not the latest ones. So even with that basics, they don't know how many transistors in 8085 processor. Okay. Like thousands, only thousands, like 6,500, around 6,500 transistors in 8085. Okay. But now today, almost 15,000, like 15 billion transistors in Apple M1 chip. M1 chip. It's Apple ones, I guess. Sorry, not M1, M4, M5, I guess. It has 15 billion transistors. Just look at this, the numbers, like 6,500 to 15 billion. So too much growth, right? Even in future also, it will be improve. Okay, so I can say this very proudly. VLSI domain will be very best in the future. Everyone needs mobiles, laptops, everything, right? So they need chips. So VLSI will have that value in the future. So you don't need to worry about the future. Okay. Now, why it's a high growth means first, latest things are like a government is spending too much money on this chip production. For example, in Gujarat or Tamil Nadu, they created some plants and they are giving jobs. Okay, like they're investing too much money. Why? Because we're like in India compared to South Korea or America or Canada, other countries. Okay, they are so fast actually. So we are trying to reach them. Like for example, TSMC. By in Taiwan, there is a company called a TSMC. Okay, they will produce 3 nanometer transistor based chips. Okay, but India, we don't have that facility. We're creating now. So in the future, we will have those kind of facilities and infrastructure in the future. No need to worry about that. Okay, and okay, the main thing, ASIC. Lot of people will get confusion about this ASIC FPGA. Most of the people in colleges, okay, they will listen about FPGA. Okay, FPGA, field programmable gate array. Okay, most of the people will know about that, but no one knows about ASIC actually, because ASIC is something like a very practical, very something like a industry standard. FPGA also industry standard, but compared to ASIC, FPGA is just a small thing. Okay, so there is some difference between both ASIC and FPGA. These two concepts are inside VLSI only, but today main concept is ASIC. Why ASIC is better than FPGA and what inside ASIC? We will discuss about that. Someone turn mic on. Please turn off the mic. You don't have any questions. And okay, let's start. ASIC, application specific integrated circuit. Okay, integrated circuit means our chip. Okay, chip called as integrated circuit means it's like all the transistors on a single chip is called integrated circuit. And placing on that chip is called VLSI. Okay, don't get confused between both the VLSI integrated circuit. Okay, IC, it's just a chip. Okay, so chip can be made in different types. One is ASIC and other one is FPGA. Okay, what is ASIC? Application specific means we will create the chip for particular application. For example, we will create a chip for lift or washing machine. Okay, like particular application. For a mobile, we will create one chip. We can't use that chip to like a car or lift or something, right? We can't use. Okay, so application specific integrated circuit means only it has only one job. Okay, it will be like a mobile or laptop or other cars, everything. Only one job. So another one, FPGA, field programmable gate array. This is totally opposite for ASIC. Okay, FPGA is something we can reprogram. Okay, it has some advantages. Okay, those advantages are reprogrammable FPGA. But the problem is FPGA boards are very like big in size and costly, and only advantage is we can reprogram. Okay, so the problem, there are a lot of problems with FPGA. We can't use it in everywhere, but we can use this FPGA for prototyping before creating ASIC. ASIC is something, if we create once, we can't change. So we should be very careful before creating it. So at that time, we will use this FPGA for prototyping. If everything works well in this FPGA, then we can proceed to ASIC. So main point is ASIC is a very complicated one, but we need this ASIC only compared to FPGA. Okay. Okay. Next. So don't forget ASIC and FPGA are not same. Okay. Moreover, companies always wants to create ASIC only. Like FPGA is very low. It's like a 20% market share. It's about 20 or 15% only. Most of the market share is by ASIC only. Okay. So this is about just basic details of the VLSI. Okay, like what is VLSI and growth and this comparison. What is ASIC and what is FPGA? If anyone has doubts, please raise. Okay, don't just feel free. Okay, just ask the questions. No questions. You can ask. No issues. No. Okay. All right. Let's proceed to next one. Okay. ASIC flow. Okay, this is just a flow. Like, for example, we have lot of works. Then we will do like a scheduling or something like one by one, one by one. Similarly, in VLSI also, this ASIC flow is very important. Okay, every company or every project will based on this ASIC flow only from the step one to last step. These are like around here 12 to 13 steps, but in general, it can be 10, it can be 15 or 20. Okay, majorly this is the ideal one. Okay, from this, like they will change, they will rearrange it, not the entire flow. Okay, so let's go one by one. Okay, first one is specifications and requirements phase. Okay, and one request, instead of texting in the chat box, please raise the question. Okay, I can't get into the chat box and coming into PPT. Okay, please. First, specification and requirements phase. This is the initial. For example, if a company got one project, okay, one project for other company or one customer, the main thing that customer will tell is specifications. What kind of IC or what kind of chip he or she needs. Okay, those are the specifications. For example, this processor or this CPU should have 8 cores or 6 cores. Okay, and the functionality wise, it should do these things or it should have AI in that. Okay, and some other things like how many times that project should complete in, like for example, for 6 months or 1 year or 5 years. Okay, yes, so some projects I will do in 5 to 10 years also, because I mean those are long term projects. Because for example, let's take one basic one car or mobile. Okay, let's take one mobile, and it will get a lot of versions one by one. Every year it will get a better versions, right? So one team will take care of that versions. Every version they will take care, and they will update the processors every time. Okay, so that the time, cost, everything, they will speak about all the things in specifications and requirements phase only. This is the initial thing. Okay, so what are the job roles for this? Okay, this is important, right? And if we know the information, but if we don't know the job roles, then it will be something like, okay, we know the destination, but we don't know the path. Okay, something like that. So system architect and senior design leads, these are not for the freshers. Okay, these are like 20 plus or 15 plus, 10 plus experienced people. Why means they can understand specifications and requirements very better compared to fresher, they can understand better. Okay, architect means almost 20 plus year experience. Okay, senior means okay, 5 to 10 plus. Okay, and after getting specifications, okay, one company like for example, there is a company called A. Okay, it got one project. They got the specifications and requirements also. So the next step that that company will do is design, architecture design, not RTL design. Okay, some people will think it will be RTL design coding. No, before that there is one step. It's called architecture design. First, we need plan before doing something. We need to have the plan, right? So they will create one architecture design. Okay, something like okay, what exactly is the chip and what are the modules inside of that? For example, if there is one SOC, okay, consider this image as SOC. Inside CPU, caches, and I mean memories and the GPUs, there are a lot of things. First, we need to create a architecture, where to place, which thing to place. Okay, all these things under architecture design. Until now, nothing. Practically, we didn't nothing. Just some planning only. So next step is the main thing. So this all things front end. Okay, we will talk about this front end now. RTL design. Okay, this is one of the most popular roles in our India. Okay, so RTL design, what exactly it is? Now from here, the coding will start. Okay. So RTL design is, in simple terms, we will code how the chip works. Okay. Like for example, we need a chip. It should work in one automatic car. Okay. So we need to write that code, how the chip should work. Okay. We will write the code and we will test it. We will send to the manufacturer. Okay. So main step is we need to write the code. This is called RTL design. Okay. And in this design step only, there are a lot of types. We can write the coding, lot of variations. Okay. Majorly there are 5 types. So we can write a lot of types. Okay. So this is the major thing. Okay. We created like we wrote some code, but someone needs to verify it, right? Okay. So one thing before that, job roles about this RTL design. This design engineer, it's called as design engineers. Sometimes there is no RTL in job description. They will miss RTL, but design engineer means they will write codes. Okay, this Verilog codes, Verilog or system Verilog. Some people will ask maybe why not VHDL? Okay, but India follows most of the things from US. Okay, in US, most of the companies will follow Verilog or system Verilog. These two are the languages. VHDL is represents from like Europe. Okay, we don't follow Europe things majorly. That's the reason most of the companies will use either Verilog or system Verilog. Mostly Verilog only. Okay, this system Verilog is advanced version of Verilog, but still they will use most of the times Verilog only. Okay, it has some advantages. Okay, we will discuss about that later. Okay, finally we wrote the code. So someone needs to verify, right? Like next one is functional verification. Okay, functional. Okay, what are the features? What are the functionality we need to verify? Okay, all these things under functional verification. In short, verification engineer. Okay, verification engineer will verify this particular RTL. Okay, this design needs to be verified. Okay, that's the job of the functional verification engineer. Okay, and these two parts of the you will, I mean, there are a lot of things like job descriptions. There are a lot of jobs design verification. Okay, these two parts are the design and verification. Okay, they will club these both. Why? Because some people might interested in design. Okay, writing codes, and some people are interested in verification. Okay, even verification also coding only. Okay, it's nothing different. It's also one coding only. Something like, just look at this design, this picture. This is the design. RTL engineers or RTL design engineers will create it. Okay, only code only. Nothing, no physical chip as of now. Okay, in systems, we will create the code. This is a design job. After this functional verification, people also will write code. It's called a test bench. Okay, what exactly this test bench will do is it will verify the design. Okay, it will send some inputs and it will get outputs, and it will verify, it will compare. Okay, so the importance of this functional verification is around 60 to 70% of the project, like a cost, time, and efforts. Okay, 60 to 70% on verification only. Why? Because we created one chip, okay, without verification. Okay, after creating physical chip, if something happens, like for example, we are in the lift, okay, at the second floor, we need to go to the up, like fourth floor, but lift works differently. It went to zero, so that a lift got some like a malfunction, right? So that cost, time, everything waste. So verification is very important. That's the reason we will write this test bench codes and we will verify the design. Okay, so this both design and verification is one of the popular one in India. Okay, there are only 2 to 3 popular stages in the India. So one is design verification. Okay, these two steps in one stage. Okay, and but in companies there are different teams. For design different team, verification different team. Okay, like if we know the design verification, we can get into design or verification. Okay, I hope you got enough clarity about design verification. Okay, uh, anyone have any questions about this design verification? Most of the people wants to enroll in design verification only after graduation or something. So if you have any questions, you can ask. Maybe most of the people knows about Verilog, right? In recently, a lot of colleges introduced Verilog in labs instead of VHDL. So anyone knows about Verilog?
Sir,
Yes, yes.
for functional verification, what type of languages are needed, sir? Like
Functional
system
verification.
uh,
Okay. Yes, yes.
medium
Good
also, sir.
question. Yes, yes. Okay. For design, Verilog is very important. Okay. System Verilog is optional actually. If we know system Verilog, it will be good. If we don't know, still we can survive with the Verilog, but better to learn system Verilog also. And what's the difference means Verilog is something like static language, like it doesn't have any OOPS concepts. But system Verilog is it's a dynamic one, like it has OOPS concepts. With the OOPS, we can do a lot of wonders. That's the reason there is a lot of difference between Verilog system and Verilog. But most of the companies are using Verilog. Okay, so for design, this is okay. But for functional verification, system Verilog is very important. We can verify design with the system Verilog also. Okay, this is something like it will give some confusion, but Verilog is for RTL design. Okay, no more discussion about that. But system Verilog, we can write design, we can verify. Okay, it's I told right, it can do wonders. It can do both jobs, system Verilog. So for functional verification, we need system Verilog and UVM. Okay, this UVM is a wrapper. Okay, wrapper of the system Verilog. Okay, it's not a language. It's just a wrapper. Okay, for example, most of the people knows about Python, right? Python has some libraries, kind of. Okay, some frameworks. Like for example, this NumPy something, right? Similarly, this UVM is some framework of the system Verilog. These two are very important for verification, functional verification. So if you know Verilog, system Verilog, UVM, these three things are very important. Then you can be a design verification engineer. Okay. Even most of the training institutes will teach this only. Okay. But market is moving so fast. Okay. With these three, we need to learn some other things like protocols. What is this protocol mean? Protocol, just as some guidelines. Okay. Guidelines or rules kind of. Okay. It means, for example, we are doing some data transfer. Okay, let's imagine we placed one pen drive to laptop and we are doing some transfer. There, data is moving. So we need to we need to control that movement of the data. Otherwise, that the data can corrupted or it can store into some random locations. Okay, we need to control it, right? So there we placed some conditions kind of like it's more like guidelines. So it's called as protocol. It has some guidelines, okay, for the data movement, like a data changing from one place to another place. So these protocols also important concept. It has a lot of protocols in our market. There are a lot of protocols. At least 2 or 3 protocols for this market is totally fine. Most of the people will learn one protocol and will try to get a job, but there is a real problem. At least 2 to 3 protocols we need. Okay, protocols mean not a languages. It's very simple. Something like there are small protocols, large protocols. We can learn like if we need something like there are AMBA protocols. If you know there are AMBA protocols, it has some major 3 protocols like inside chip and outside chip. Okay, protocols can be inside chip and also outside chip also. So there are a lot of things and we can learn 2 to 3 are totally fine. No need of too many protocols. Okay, so confusion, it will give confusion. Next. Okay, we wrote the code and we verified. Okay, first step completed. Okay, now after verification, this verification engineer will tell, okay, this design either correct or wrong. Okay, if it is wrong, then these design engineers will do modifications and they will make it correct. Okay, that's the main objective of the verification, right? Okay, after successful verification, design is good. So we will go to the next step. It's linting. Okay, it's not a something like a special step. Actually, it's a sub step. Okay, it's a linting. Linting means even after the verification, okay, complete verification, all the functionality is perfect, but still we need to follow some guidelines to write the design code. Okay, like something like quality check. Okay, this linting, it's not a big step, a very small step. Design engineers will do that. Okay, or DV engineers, design verification engineers will do that. Linting, the small tool based, we will check whether the code is according to the guidelines or not. Why? Because if the code is not according to the guidelines, it might give some errors in the future. Okay, this is a $1 million or $1 billion projects, right? These semiconductors, right? So we need to be careful in every stage. Okay, we want to do all these works in one stage. Okay, we will have specific works. We won't do everything. For example, if verification engineer will do only verification, not the design part, something like that. And the clock domain checks means it's a different from linting. It's related to some timing things. For example, every code has some clock. Clock means something. For example, we have clock in the daily life, right? Similarly, shift needs to work based on the time, right? So it has some internal timing. It's called as clock. So clock related things, everything. This clock domain checks. Will those engineers will check. So DV engineers will check it. Actually, most of the companies, design people will do this linting and the clock domain checks. Everything design people will do. Okay. And after this, the main conversion synthesis. Okay, until now front end only. Okay, even this synthesis, this is a something like it's a kind of conversions. We wrote the code, right? It's kind of English, almost English. Code is something like English, but we need to translate it, right? We can't place English inside the chip. Chip is chip having transistors. We can't give English, right? They don't understand. So we need to give something they can understand. So it is gates. Yes, gates. We studied about gates, right? Basic gates, universal gates, special gates. Yes, those are the main important things. Those are called as standard cells. Means all the code we wrote previously as a design engineer, it will convert into gates. Yes, it will convert into gates only. Gate means internally gate have transistors, for example, and the gate has having like around 6 to 8 NAND gates or NOR gates, something like that. Okay, so end of the day, we will convert into gates. So it's called as gate level netlist using some tools. We can't change it orally or with hands. Okay, it's just something like there are some tools. With those tools, we will convert the design into netlist. Netlist means gates, just gates. Okay, why? Because we will give this design, I mean, this gate level netlist to PD, means physical design engineers. Okay, so we need to create it and we will give to the back end team. Until now, from up to here, it's only front end only. Okay, front end engineers or design verification engineers will do until synthesis. Okay, from here onwards, back end people will start. Okay, this is about front end. And there is one more role. It's called DFT, design for testability. Uh, the thing is, this is not a neither front end nor back end actually. It's something like in between both. Okay, so this is a one more famous one for famous role. Okay, we have three roles, famous roles. One is front end, total front end design verification, as we discussed earlier. Second one is design for testability. Okay, DFT. And what exactly this design for testability means? For example, after writing a code, everything, okay, we converted into netlist, right? Here, netlist. So after netlist, we will add some, we will do insertions, okay, scan insertions. There are a lot of things. This is some technical thing, okay. And we will add into that gate level netlist. Okay, why? Because at the end of the, like, for example, we are adding this in here, DFT. Why? Because we will use that in last step testing. Okay, this DFT people will add those scan insertion, all these techniques to verify final chip. Okay, finalized chip. Okay, that's the reason DFT also very important. Every step is very important. Okay, but majority of popularity of the roles in India we need to consider, because if we learn some other role and if we try to popular one, then we will get a lot of issues. So design for testability role is DFT engineer. Okay, until now front end is completed and even DFT completed. Okay, so is there any questions, any doubts about front end or DFT? No questions? Just ask questions if you have any. Like we need to clear all the doubts, because we will get into VLSI in future, right? So we need to know a lot of information. Information is really kind of wealth. Okay, if we know a lot of information, then we have a lot of wealth. Okay, so any
So
questions? Please raise.
for
Yes, yes.
RTL design, we need to protocols, sir.
No, for RTL design, we need protocols, but not like verification. For example, not like verification. We need to know how to write the protocol. Yes, we need protocols in design also. Specifically, some protocols.
Okay, sir. Thank you.
Yeah. Any other questions? Okay, perfect. And next one is after DFT. From now, from here, backend will start. Okay. And after synthesis, floor planning. From here onwards, backend. But still, they don't work on physically. Okay, still in the tools only. Even backend people will work on tools only. Okay, they don't work on direct chip. Okay, floor planning. Okay, it's something like a basement. Okay, they will plan how the chip should be in physical, like which block and at which place, all the things. This floor planning stage they will decide. Okay, from here physical design engineers will have that. Okay, floor planning is one of the part of the physical design. Okay, physical design, they are designing, okay, physically, like chip, how chip should be, something like that. Okay, and next one. Okay, in this only, here you can see chip or block layout planning. It means chip planning, exactly, like which block where everything they will plan. And macro placement, something like small things like connections to outside world, they will plan everything in the floor planning. Okay, just planning only here. And after that, practically placement and routing, this is very important. Okay, most of the times errors will come in this stage. Why? Because here placement means just placing all the things like standard cell. What is the standard cell means? Gates. Yes, we discussed earlier, right? Gate level netlist, right? We will place those gates in that particular place. We fixed the place in floor planning, right? So now we will place that in that particular place. And routing. Routing means connections. As you can see, this core, memory, IO, analog, everything, right? So in between, there are a lot of connections. Okay, those connections, this routing stage will take care of that. This physical design engineers will take care of all the placement and routing, floor planning, these all things. Physical design engineers will take care of that. Okay, and even in this stage also, they work on tools only, not the physical chip. Okay, like they will connect everything in software, and at the end they will apply it into that particular physical chip. Okay, before that all the arrangement needs to done, right? So these people will create all the arrangements. Next, okay, before that, clock tree synthesis. Okay, this is very important. Clock tree synthesis means all the blocks inside a chip needs to get the clock. Everything will work based on the time, right? So they need clock. So we need to give the clock for every block. Sometimes we will get errors in this area because maybe one block will get a clock too fast and one clock will get a clock too slow.
సార్
Yes, yes.
సార్ ఒకసారి క్యూ లిస్ట్ లో ఉన్న వాళ్ళని యాక్సెప్ట్ చేయరా?
Okay, yeah, well, just 1 minute. Yeah, only one person. Yeah, done. Okay, so yeah, okay, some more people. Okay, got it. And next one. So we need to give that clock for every block. Okay, without any delays or something, we need to give equal times. Otherwise, some blocks will start too fast and some blocks will go too slow. Everything, it will be a mismatch kind of. Okay, it will give only errors only. So this clock tree synthesis is also very important. These are all things physical design engineers will take care. Next, static timing analysis. Okay, this step almost similar like a math. Okay, there are a lot of equations, everything. Why? Because we will calculate a lot of things about timing. Okay, for example, if we click on particular app, okay, app needs to open like in 2 seconds, but for some reason it's not opening. For after 10 seconds, 15 seconds, it's still not opening. Okay, it will be a issue, right? Because internally the cores are not doing the job because of clock issues. There are a lot of things, there are a lot of issues. Okay, so to deal with that, these static STA engineers, okay, basically these STA engineers will calculate all the timings and they will do the requirements for to get the perfect timing, to get the perfect output. These people will do. Okay, it's based on tool. Even this stage has tool on the in that particular tool based on mathematical conditions, some mathematical things. They will find out the timings. There are two things: setup time, hold time. Okay, there are two times, and setup time means something like a positive edge, and hold means a negative edge. Okay, there is some in detail one. Okay, and so they will calculate these times. Okay, based on that we will get proper output. Okay, this is very important. Even after creating whole chip, if the timing fails, then it will be a waste, right? So this STA engineers job role is STA engineers, static timing analysis engineers. After physical verification, okay, this is a part of PD only, and the sign of all the things we'll do in this step only. In this, there are a lot of sub steps like DRC, LVS, ERC. Okay, maybe these names will be confusing, but I will tell you what these roles is. DRC means design rule check. Something like there are some rules for physical design. Okay, there are some companies like TSMC, like Samsung. These companies propose some rules for design. What design? Not the RTL design, not front end. It's for back end. Okay, chip should be something like this or something like that. Okay, they created it, some rules. So every company should follow those rules for better output and for less errors. Okay, DRC is design rule check, means it will check the physical design, whether it's obeying the rules or not. Okay, and LVS. Okay, something like yeah, layout versus schematic. It means like we have layout, right? Initially we created some layout. Even there are some people called analog layout engineers, they will create some layouts. Okay, after creating this physical design, we will compare it whether it's similar or not. If it is different, then it will be a problem, right? It should match, layout should match according to our plans. And next, ERC. ERC means electrical correctness. It will check electrical correctness. Okay, like all the transistors are getting proper power or not. And maybe if some transistors are getting too much power, then it will be a problem. Maybe short circuit or a lot of things will happen. So ERC also, all these steps are very important. The inside physical verification. Okay, after this, every in project, if all the steps are good, then we can proceed to next one, like ending part. Okay. Next one is tape out. Tape out. Okay. It means like, okay, this is end of the project. We need to give this plan to fabrication unit. Fabrication unit means manufacturing company. Okay. There are a lot of big tools. Okay. In that, we will give this plan and it will create the physical chip according to that plan. So this tape out is a ending one. Tape out after fabrication will happen. So how exactly it will happen means after creating everything, even physical verification also completed, then they will create one format. It's called as GDS2. Maybe you will get this GDS2 in some like a SWAYAM courses, all the things you will see this GDS2. What exactly this means? It's a kind of format. For example, if we have some video or audio MP3, MP4 formats, right? Similarly, we need to give the details in particular format. So this GDS2 is the format. It will send to foundry. Foundry means fabrication or manufacturer unit. Okay, this is a GDS2. So this fabrication unit will create. Okay, it will create the chips physically. Okay, with the tools. It will take weeks, months, a lot of time. Okay, based on the complexity of the chip. If it is 500 nanometer, and then it will take less time. If it is 3 nanometer, it will take a lot of time. Okay, to incorporate a lot of transistors, it will take a lot of time, right? So previously in 8085 microprocessor, it's a something like 600 nanometer or 6000 nanometer, something like that. But now today it's a 3 nanometers. Even some companies are working on 2 nanometer. I told you one company, right? TSMC. Okay, Taiwan Semiconductor Manufacturing Company. So it's working on 2 nanometer. Okay, technology is growing and new technologies are coming, but this flow is standard. No need to rearrange or anything. Okay, okay. Now chip completed, created, physically created, but still we need to check because even in physical creation also maybe some errors might come. Okay, there this post silicon validation and testing will happen. This is the last stage, testing. Finally we got a chip in our hands, but still we need to verify it before giving it to customer. Okay, this is the last stage of testing. It's called post silicon. What it means, previously all the roles are pre-silicon, pre. Okay, this is post-silicon. Why? Because we got the silicon chip, right? Now we are testing. It's called post-silicon validation. Validation also testing on it. Okay, two different names. Maybe you will see this validation word more frequently. Okay, even more than testing, you will see validation name only. And roles. There are some roles, AT engineers, post-silicon validation engineers. Okay, these people will work on the final test. Okay, sometimes like there are very few companies have this testing ability, not everything, because it needs a lot of infrastructure. Okay, some cool rooms and everything, those big machines, everything they need to have. Okay, this is end of ASIC flow. Okay, so so tell me, in which particular stage I mean, like, do you have any questions in any stage, or all stages are clear? Please raise questions. No questions. Okay. Okay. Now, how to select a particular role? Okay. In India, majorly there are three roles. Okay. Like those high demand roles. Those are, first one is design verification. Next one is physical design. These two are very popular. Okay. Most of the people will take either design verification or physical design verification, PD, DV or PD. But some people will take design for testability or DFT also. These three are highly demand. Okay. They have too much demand. And why means most of the projects based on these teams only, design verification or physical design only. Okay. So more project means more hiring. So that's how they will recruit more people for these roles. And there are a lot of other roles also. Okay. Like STA and analog layout, AMS verification, post silicon validation, ATE, emulation, FPGA prototyping. There are a lot of roles, but they are not that much popular. Okay. And these are the something like a very rare roles. So if you want to select particular role, then go for design verification or physical design or design for testability. Okay. Why? Because design verification can have like both design and verification. Anything you can jump. Physical design, you can jump into STA or post silicon validation. This AT both are same, and other roles. And DFT, single role only. So you can select one of these three. Okay. And next, one main important thing every college student should know. Okay. There are two types of companies. One is product based companies. Second one is service based companies. Okay. In the name, just look at the name, product, service. Product based companies are the big companies. For example, Samsung, Intel, and Synopsys, Cadence. There are a lot of product companies, right? Why product means they will create it. Okay. Instead of doing service, they will create product directly. Okay. But service is totally different. For example, in service based companies, those are small companies. Okay. Not the big companies. So those small companies will hire some people, and they will send those people to product based companies as client. Okay. Client projects. And yeah. So if you want to better career, you need to jump into product based companies. But that I mean, product getting into product based is really hard. Okay. So even service based also good. Okay. Service based is not bad. Both companies, both are good only. Okay. But the something like get product very fast in product compared to service. Sometimes even pay scale product will give more more pay package. Service will give less package compared to product. Even if you land, if you get job in service, after 2 years, you can jump into product without any issues. Okay. End of the day, all the people in product based companies only. Okay. And so if you get any job in any company, just jump. Okay. Don't think like this company is so small, this company is big. In VLSI, every company is important. Okay. So you can jump without any thought. Next. So recently, like from last 3 4 years, VLSI demand, like both VLSI demand and students also actively getting into VLSI. So it increased competition. Okay, yes, competition, and entry level open less. I mean, no need to scare. Okay, just I'm telling normal situations. For example, in a year starting, we will get a lot of openings, but year end we will get small, like less openings. So entry level openings have some issue. Actually, college graduates can't get job very fast. Okay. like placement. We can't get those jobs in placements. Very rare actually. Only top tier colleges will get that. And preference is a main issue here. Okay, for example, tier one, tier two, tier three. Okay, we have tiers, right? Tier one means NI, IIT colleges. Okay, these companies will go to the tier one colleges and they will recruit directly with a high package, product companies. But what about tier three? In tier two, tier three, some people will get product based on the trainings, outside training. They will get into product. Some people will get service based. Okay, later they will move into product one. Okay, so tier two, tier three has some disadvantages. Like it has some movement, some slow movement. Like we need to wait some time compared to tier one college. Like IIT people, NIT people will get the job very fast. Okay, without a talent also. I mean, without a talent means semi-conductor talent. Okay, they will get through placement. Okay, so they have like IIT and those studies are different, but semiconductors knowledge is different. They will get the jobs. But for tier two, tier three, even though they have a lot of knowledge, they need to wait for some. No need to get scared. Okay, we will get the job. Has a lot of knowledge compared to I or other people. We need to have those particular knowledge, and we will get the job. No need to worry. Okay, and the problem. Okay, today's problem is college curriculum, industry expectations. Industry is moving very fast, right? But what about the college? It's moving very slow. Because one example is in college, most of the college will teach VHDL, right? In second year or third year, they will teach VHDL, but not very long or system very long. But the market needs very system very long. Create some HDL, but still college curriculum behind. Okay, so now we need to learn Verilog or system Verilog, all the things. So we need to have those requirements. Okay, we need to know what are the requirements of the companies. Then we need to learn those, and we need to be updated. Okay, so don't rely on colleges only. With the college knowledge, you need to have outside knowledge also. For example, you need to learn Verilog, both the design verification engineers or everyone needs to know Verilog. Very common. For example, IT. Let's take okay, they will put language at least, right? So similarly, in VLSI, the people should if you don't how to Verilog or specific role related requirements, right? So I will explain some steps how to get into either training or coaching and how to get a job. Okay, I will explain that flow now. How students enter the industry today. First one is training institutes. Mostly, majority, maybe 90%. Okay, why 90%? Means colleges won't, sorry, these companies won't come to colleges for placements. Okay, so there is a that's the main problem. So everyone will go to training institutes in our mentorship program. Mostly training institutes. There are a lot of training institutes and pay money and they will get the knowledge and will get in projects, means companies. They will get the jobs. Okay, so one main point is if you got into service company, like I saw some people, they got a job in service companies, but they never get that companies. They didn't get shifted to other IT or something like that. But it's a big mistake. If you get any company, just getting late, you will get pages because after 2 or 3 years, just come back of VLSI and other domains. Okay, without any doubts, VLSI gives best. Even after 2 plus 3 plus 5 in every stage, they will provide packages, works, every given thing will be better in VLSI. Okay, but main thing, this is very important. Okay, after graduation or even in fourth year also, people will get into institutes, right? Okay, so that means those training institutes will tell we have 100% placement. Okay, so the students will pay money and they will get into the training institutes and they will learn. But at the end of the day, they will tell like it's not guarantee, it's a assistance. Okay, no one will give 100% placement guarantee. They will give 100% placement assistance. Both are different. Okay, guarantee means they should give, but assistance means just a help. Okay, with that point, it's a loophole. Okay, so these institutes are taking too much money and giving very less jobs. Okay, so don't for 100% placement. Okay, and next one is in training institutes. Okay, more they will focus on tools only, not the entire things. Like for example, if we have some documentation, for example, we have a documentation of very long. They want to go through all documentation. They will for example, we have 100 topics as standard. They will teach the topic. Then close. Okay, so what about the rest? We need to learn. Market condition and those training institutes are doing like that only. So we need to be careful. We need to self-learn those remaining concepts. Next, certifications. This is one more thing students needs to know about this. Certifications are the not the skill. Skill certifications are the different. Companies won't ask for certifications. Okay, yes. You don't need to have 100 certifications. Okay. Even if you have 100 certifications, you won't have job sometimes. And some people doesn't have any certificates, but they can get job. Why means they have knowledge, not the certificates. Okay, don't fall for certification. Okay, run for knowledge only. Okay, and these are the things you need to be careful after or in fourth year or after fourth year. You need to be careful because you are paying money. In return, you are not getting anything, right? So just be careful. Okay, even after training us struggling to get job. Why means training institutes will teach something like a 30 to 40 or 50%. The rest they want to teach. So students won't want to do self study or self they need to check all the internet and they need to learn. Yes, they need to self learn. And one more thing, if they don't know any topic, they want to try to learn. They will skip it. We should not do that. Okay, engineering is different and this training is different. Training means professional training. This is very we need to know everything. For example, we are doing a project. Okay, in a company we're doing a project. We got one issue, so we can't skip it. Right? It's $1 billion. We can't skip it. If we skip, then whole project and they will everything will happen. So this is college. If you have any work, you should complete it perfectly. So even in learning also, we should do that. No debugging mindset. Debugging means finding error, correcting. Okay, we should have that in our mind every. Okay, most of the people forget this debugging. Very important. Okay, it's not a something like we need kind of. It means practical knowledge is very important. Means more projects needed. Okay, and one more thing is resume issue. I saw a lot of resumes. They include some other projects. For example, even I did like earlier at my starting stage, I placed one IoT project for VLSI company. Okay, we should not do those things. Okay, IoT projects, right? It's rare projects. Means VLSI needs VLSI projects only. Don't post don't include other projects. It's a waste of space in the resume. Okay, so we need to do related to VLSI only, especially particular role. For example, if you want a DB role, then you need to do some projects related to DB only. You don't need to do PD. Okay, so this issue, this problem. So don't do that. Okay, resume needs to be good and relevant. So what exactly we need to do now? Okay, fundamentals be so strong. Digital electronics. It has a lot of names like STLD or DLD, design. It has a lot of name, but end of the day, that same variational circuits, sequential circuits. We need to go to sequential circuits very good. Okay, FSMs and these concepts. We need to have these fundamentals very strong. Okay, in general, basic is very strong, right? So these basics are very, we need to know. And after, we need to have debugging mindset. Okay, if we get any issue, we don't need to get scared. We need to clear the issue. Okay, we need to resolve it. That kind of mindset will get the better, I mean, better career, better future, everything. Okay, and in each stage they should know. Like for example, if a student wants to learn design verification, then he needs to know about design and verification and everything inside of that. They should not skip anything. Okay, and mentorship and feedback. They needs to have some mentors or someone already in, for example, one mentor or one guide. Okay, they can tell a lot of things. For example, today in VLSI industry, a lot of things have, like for example, I told one word chiplet. It's a new technology coming. Still not practically, it's in theoretically. So all the things we should know every day to day, should know a lot of things. Like all the things we should aware of that. And so be prepared everything. Okay, 4 year, mostly now project time, right? Most of the people will do projects in fourth year, second semester. Okay, some people will do trials time only. So if you can do, then fine. Otherwise, my advice is just skip now. After college only, just get into training institute and learn and try for job. Why? Because this is something like we need to learn very best. So we can't do both the project and the training with two hands. Okay, it's something like standing on two boats at the same time. Okay, so don't do that. If you don't have any other option, then fine. But better to avoid. Okay, after projects, after BTech, better to enter into some institutes and learning. That way is better. Okay, so as I said earlier, fundamentals are very important. Okay, after practical knowledge. Okay, practical knowledge means projects. Yes, you need to do a lot of projects. Okay, companies need that kind of practical persons only. Okay, theoretical people, they won't care about, like companies won't care about theoretical people. So we need to do some projects. Yes, internships. Yes, a lot of product-based companies are giving internships. This is year end, right? Now it's very good. In general, year starting, we will see some roles like internship, especially from Synopsys, Cadence, okay, Samsung. Those companies will provide internships. But most of the times, they will give to 80 people only. Same story. But if we get any opening, then we need to apply it. We need to grab it. Okay, before that, we need to have better resume. Okay, don't forget that. And one more thing, stay updated with industry trends. Means day by day we are getting a lot of advanced, right? We need to know everything. Just be updated, then it will be it might give better results. Okay, they want to do any harm if we don't know, but better to keep updated. Okay, so about displacements, colleges, things. I hope everything is clear. So, does anyone have any questions? Anyone have any questions? Please raise. No questions. Am I audible?
Yes, sir, you are audible.
Okay, so no questions about placements or these training institutes or college and ASIC flow until like whatever we discussed until now. Any questions, please raise. Feel free to ask. Okay, you need to raise your voice. Okay.
Yeah. Sir, how much time it will take to get experience or get trained in VLSI?
Okay, so before that, we need to pick one role. Like for example, let's say design verification. It needs 4 to 5 months, and the physical design, similar 4 to 5 months. and the DFT 3 months, around 3 months, something like that, 4 months. So average less than 6 months only for training. Okay, not more than that. Some people will take 8 months or 10 months. No need. Just one module, 1 month. Like Verilog, System Verilog, UVM. Similarly, in PD also, one module, 1 month. Similarly, so 6 months is ideal, perfect. Even with the projects also, 6 months, perfect. Is it clear?
Yeah, it's clear.
Okay, all right. So, any questions?
Can you give any example of PD projects?
PD projects like one is, for example, recently I saw one project. It's a 28 nanometer node. For example, let's take okay, just one simple module. Okay, for example, there is a counter, very simple module. Okay, so for that, we need to know which kind of node it should be. Like for example, 28 nanometer, 10 nanometer. So according to that, we need to create it in the tool. Okay, so project both front end, back end, it has same projects only, but difference is that tool and the way of doing things are the different. For example, if one company has one project, okay, for example, just imagine one company got one project. It's a automatic car. Okay, car. It's a they needs to create one chip for automation of the car. So first front end people will code it and it will verify everything will be done. Then back end people will take that code. I mean, at least I told right gates everything they will take. Then start work like all inside the tool they will create a map kind of one basement. Okay, like something like this one basement and they will place all the required modules. Okay, they will place modules and they will do connections. Okay, so here project means both front end and both, like we can do both the front end and back end. There is no specific different projects. Okay, if you want an example, let's take, I mean, most of the projects are protocol based or, okay, let's take core CPU or GPU. CPU has some C related also sometimes. So let's take memory. Memory is perfect. Okay, memory has transistors and it will work on Verilog's design, everything. So for example, today we have a lot of memories, right? SSD, HDD, and pen drives, memory cards. Okay, what exactly those are? Okay, not memory card, it's a different, and pen drive also different. So memories, SD RAM, DD RAM. Okay, I guess you know about that memory classification, SD RAM, DD RAM in SSDs. And those, it's a kind of project. Okay, first front end people will code for that, like how address lines, how many in the address there are rows, columns, there are a lot of technical things. Okay, code it. Okay, later backend people will design something like, okay, inside memory there are a lot of partitions. Okay, those partitions the physical design engineers will create it. Okay, so project is same for front end, back end. Some companies want to take a front end, some companies want to take a back end. Okay, that time, for example, we are in one company. That company will take care of back end only, not front. That time we get some random project for the back end and we will get it. Okay, is it clear?
Yes, sir.
Okay, any questions?
Yes, I have.
Yes, please proceed. Tell.
So according to the current trend, which has more opportunities for as a fresher, as a PD or digital design verification?
Okay, the thing is both, right? This all three roles has better, like not these roles. These three has good demand, like design verification, physical design has more. Even DFT also rising. Lately, DFT also has a lot of demand. Both the three roles has good demand, but these roles very rare. Okay, don't seek for these roles. Instead, go for these three only. Okay, even in these three, you may get a doubt. Okay, which one to pick, right? So if you love coding, no, that's not a good thing. Even some people don't love coding. Okay, they will do better coding in practical. So, are a good way. Okay, design verification is something like a coding and something debugging. Okay, if we get any issue, we need to solve it. That kind of mindset. But physical design is totally some like a totally different story and a tool based. And we need to plan. We need to have the plan in our mind. Everything we need to. So our interest. It's based on interest. Design verification is part of coding only. Physical design will have coding, but it's not like if you don't love, if you hate coding, you should not take physical design directly. Okay, this coding is totally different. This is not IT. Coding is totally different. Even one person who don't likes coding will do the coding. Okay, that's good. The coding thing. Like in VLSI, coding is really good. So just look the like a syllabus or a brochure of the either design verification or physical design. Then think, okay, can I do or mathematical things? In physical design, we need to know some mathematical things like static timing analysis. We need to know math, right? So there are some formulas. Time means math, right? So we need to know formulas. Okay, we need to calculate. Actually, tools will calculate, but we should encourage it. So we should have that before getting job. Interview, we don't have any tool. We won't have any tool, right? So we should know everything. So if you have math interest and diagram design interest, then you can go for physical design. No, I don't have that. If you don't have that interest, then you can go for design verification. And what about DFT? This is growing recently. Okay. So sometimes you won't get this DFT courses. If you get, then fine. Otherwise, mostly go for either DV or PD only. Okay.
Okay, sir. Thank you.
Okay.
Sir, how will be the hiring process in the companies, sir, for these roles?
Okay. Okay. So DV roles or just a design?
For both,
Psychiatry.
sir.
Okay. For a DV, in general, let's take one company. Imagine one company is a hiring DV engineer. Okay, first they will either first most of the companies will give a written test only. Written test means they will ask digital Verilog. As a first stage, they will ask those questions. So that's the reason our basics should be strong. After that, in interviews, if it is a DV role, then they will ask both design and verification, system Verilog, UV. Those other languages they will cover. If it is only design, they will ask about synthesis or linting. I mean, I explained earlier that those topics and Verilog importantly. Okay, they will give some situation based questions. For example, let's think if you got one error, you need to debug it and you need to verify it. Okay, at that time, which or what kind of approach you will take? These questions are the very frequent questions. Okay, so we should answer. Even if we don't know the answer, we should be very confident. Okay, some people just you know the answer, but you can't tell because of nervousness. Okay, just be prepared for interviews and be confident. Okay, sometimes nervousness can kill the answer. Okay, we can't tell because of nervousness. So just be confident. Advice is even if you don't know the answer, be confident. Sometimes it will be correct. Okay, sometimes they will think like, okay, these people are so confident. Maybe they will learn in the future. Some kind people are there, right? So they will think like that. So Verilog is very important with the digital electronics for DV after specialized like system Verilog and UVM. These all things are very important. First is written test most of the times. And one more thing, core for VLSI engineers, they think like aptitude and C are not needed. But some companies will ask. I mean, not every company, but there is a probability. Okay, aptitude and the reasoning, right? Like something like not so 15, 10 questions, something like that. They'll ask. Yes, some questions, some companies will ask. Even C also. Yes, C also. Some companies, not every company. It's a something like to test how much knowledge they have. That's the reason they will ask a C and aptitude. But not all the companies, something like 20 to 30% companies. So better if you know those concepts. If you don't know, still. Okay, Sai Kirtana.
Okay.
Okay. Any other questions?
Hello, sir.
Yes, yes.
Sir, for a fresh to crack a job in physical design, what are the things he has to be prepared in? Like, what are the topics, scripting languages, and what are the tools he has to be known?
Okay. There are a lot of tools. Tools are it's not a big problem because you will get the tools in everywhere, like in the institute or company. So tool. One more thing is each company will have different tools. Okay, not same environment. For example, in my training institutes, some training institutes they will use some company, A company. Okay, in my company they will use some other some other tool. Okay, tools are like a lot of tools available. So don't think about the tools. Uh, Knowledge, like what are the subjects we need to learn? That's very important. So you ask for scripting language, right? TCL for physical background, we need to know TCL. TCL is a scripting language. What about design verification means they should know TCL and Perl and Python. Anything is fine. For backend, TCL is very important. And this STA, these concepts are common, but a scripting language TCL is really important. Is it clear, Varun?
Yeah, yes, sir.
Any other questions? Hopefully every doubt is clear. Okay, let's go to next topic. And okay, this is not the ASIC concept. Just it's behalf of Silicon Verify, and this Silicon Verify is training institute. Yes, it's an institute, and here the people will teach you design verification. As of now, design verification only, not the physical design. It's still in the progress to create the physical design course. As of now, we have design verification. So just in case, like. The market is totally like unpredictable. A lot of institutes are don't fall for that. And for example, one guy I know, like he took one course from one institute. Okay, for they told 100% placement. Okay, he fall for it and joined something like that, 70 to 80,000 something. So not a big one, so not a small one. But after enrolling into that, he knows about like no placements and 70,000 or 75,000 wasted. Okay, even knowledge also just half baked, not the good thing. Just some non-experienced people just explained something. Okay, so selecting institute is very important. So we created some good curriculum according to that. Okay, for design verification, we created some good curriculum. So this program, okay, design verification only. As of now, we don't have PD. We will update everyone if we have PD in the future. Okay, so this design verification will be 4 to 5 months. As I told, 4 to 5 months needed for better explanation, projects, everything. 5 months needed. Okay, and the certification, it's a very common. Everyone will give certificate, but don't fall for that. Okay, and timings, it's a totally 100% online. Okay. Why? Because a lot of people think online or offline. Okay, this topic is totally different. On or off. Okay, some people will think like one person told offline is better, one person told online is better. Okay, actually our efforts are more important. Online or offline, it doesn't matter. Okay, uh, in I will tell online is better than offline because even in offline you won't ask too much questions. In a room full of 70 to 100 people, you need to ask questions. And social anxiety, nervousness, you won't ask any questions. Then those questions will dead. You want to get the answer. Okay, but in online, you can turn on the mic, you can ask. Okay, and you can get the recordings. You can watch those lectures multiple times, right? Those are lot of advantages with the online. just in case, like I'm telling this for some people who seek for offline only. So even online is better, and like availability of recordings, and you don't need to move to other place. Okay, if you want some offline, you need to move other place. Then you need to pay more money, like a PGs, traveling, everything. Okay, but online, it's a you can reduce lost a lot of money. Okay, just think about that. Okay, and do whatever like you need just to do it. And our program, we will give that, I mean, we will provide the tools, and we are MSME registered. MSME means it's an Indian one, all national one. We are registered, and access. We will give recordings. Yes, but what's the specialty with other institutes? So we will give future content updates also. Okay, other institutes won't give these kind of updates. For example, let's imagine one course completed, they won't care about that person after that. Okay, but we give future content, like if something happened in future, we will provide the related things. Okay, so everything will similar to other institute, only some good things we had, something like a future thing we can give more updates, and recordings, everything we will give. And online, and flexible timings, something like evening, so you don't need to worry about academics. Okay, even for listen, you don't need to worry about the project or college, and you can work on the academics on the day, and evening you can work on the this role. Okay, and internship after the course, you can get the internship, even stipend based internship also. Based on the performance, you can get the stipend based internship also. You can do a lot of projects. Okay, and some projects. So this is design verification program structure of Silicon Verify. Just in case if you are interested, please reach us. And what about the pricing? This is very important, right? Comparing to, we don't want to compare other institutes at this thing, because others are charging something like 1 lakh, maybe 1 lakh 70,000, 80,000. It's not about money, it's about knowledge. Are we getting knowledge or not? Okay, we Silicon Verify will guarantee you will get a knowledge, and you will do projects, everything. So program will be 20,000, but for the first 20 to 20 students, we will give some offer kind of. So it can be 10,000 only. Okay, if it is one time or two, I mean, two installments, you can pay, you can get it for 10,000 only. Okay, if it is three installments, you will have 12,500. But just, okay, less money means not less knowledge. Okay, better knowledge actually. We will provide better knowledge, better than other institutes. Okay, but for less money means we don't want to take too much money, and we don't want to be rich. Just we want to spread knowledge. Okay, we know we need community. Okay, we need to have connections, community, these things only. Okay, not the money based and these things. Why? Because of these 10 or 12,500 things means tools. We need to provide tools, right? And we need to provide a recording, all these things. So some basic things. Okay, so that's how the fee and enrollment. So we will post some forms, like a Google Forms in the group. Okay, just fill that form if you are interested. And moreover, the main important thing, please compare with other institutes. Okay, and and take the good choice. Okay, and okay. So any questions? All the things from start to end. Please raise question.
Hello.
Yes, 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 Lokesh.
Sir, why it's very, I mean, you told right, other institute charging very much, like 1 lakh, and why we are very less? May I know the reason?
Yeah, that's a good question. As expected, actually, other, for example, let's take one X institute. Okay, we can't tell names, right? So we don't want to defame any institute. Okay, we need to encourage everyone, but we can't defame. So let's take one institute. Okay, they are charging 1 lakh. They told 100% placement. Why they are charging me? Charging too much money means they're investing for placements, but they're not getting. That's a secondary thing. They are charging too much money, but they are telling like, oh, okay, we are giving placement. That's the reason. It's a bullshit. They are not giving anything. It's a very few jobs they are providing, but they are charging money. The only way they can get money is through education. We know this, right? It's a business for some institutes. We don't want to do that thing. Okay, we need to improve the student, like their knowledge, their situation. Okay, so we don't want to do something like other institutes. We want something special. Okay, so we are following with these less prices. Is it clear, Lokesh?
Yes, sir. Thank you.
Okay. Any other questions? Anyone? Okay, so no questions. Okay, fine. So I'm asking again. Please raise your questions if you have any. Okay, feel free to ask. Any questions? Any doubts about ASIC flow or course or technical concepts or anything? You can ask. Okay, fine. Yes, no questions. Okay, so thank you everyone. So for your joining attention questions. Okay, so if you have any further questions, okay, even in future also, if you get any questions or doubts, you can ask in that WhatsApp group. Okay, free of, I mean, it's a free. We don't charge for questions or something. Okay, you can ask questions, you can ask for guidance, everything you can ask in that group. Okay, and about that course, I will send Google Forms and brochure everything in that group. Okay, so take your decision. And thanks for CR Reddy College IEEE and for this opportunity to share the knowledge.
Thank you so much, Mr. Indra Reddy, sir, for such an insightful and informative session. Your valuable guidance on the VLSI industry, ASIC flow, and career roadmap has truly inspired all of us and will greatly help students in shaping their careers in the semiconductor domain. As a token of our gratitude and appreciation, the IEEE Sir CRR COE student branch would like to present a memento along with a certificate of appreciation to Mr. Indra Reddy sir for sharing his time, knowledge, and experience with us today. Sir, this small gesture is a mark of our sincere thanks for your wonderful contribution.
Yeah, thank you. Thank you, Priya.
Once again, thank you, sir, for sharing your expertise and making this session a great success. We look forward to many more such interactions in the future, sir.
Yeah, sure. Even with the new technologies, I will take a lot of webinars even in future.
Thank you, sir.
Oh, maybe session ended. You can leave.
Thank you, sir.